connected with methyl here. Here it's a Br. Here it's a H. Here it's carbon. Here is H. Here is Br. And here is CH3. Okay. Right? Now, you can tell me whether there is any plane of symmetry, center of symmetry, and chiral center is present in the system, and whether this compound will be optically active or inactive or show optical isomerism or not. Get my point?
Yes, ma'am. Here there will be no plane of symmetry.
No plane of symmetry.
But
Okay, so no POS.
Center of symmetry will be, so it will not show optical activity with chiral centers.
Is there the center of symmetry?
Yes, ma'am, because opposite and the same distance, they are the same distance.
Okay, so it will be optically active or optically inactive?
Inactive,
how can you say that there is? How can you say that there will be center of symmetry?
Because if you take a point at between two carbons at mid, the bond joining the two carbons.
Yes. So see, if you are having this, then you can't go here and here now. It is not in the same plane. Like the question, the plane that we saw, is it like this now? So then you will go in the opposite direction. But when something is present here and something is present here, how will you go in the opposite direction? Because when you draw this Fisher diagram into the normal structure, so you know that how you will put like in a dash and a wedge part. You're getting my point? So there will be no center of symmetry also.
Yes, ma'am, because depending upon the bonds we are going to see.
Yes. Okay, so when you actually convert this Fisher form into the normal form, you will see that there is no center of symmetry as well here present. So if no POS, no COS, and chiral center is there, then
will show
it is optically active. Okay. Optically active. So this will show the optical isomerism. Now if I say this compound is second compound and this compound is first compound, is there any relationship between the first and the second? Tell me. Is there any relationship between the first and second compound? Are they superimposable mirror images of one another?
No, first one. Ma'am, no, we
you
can.
have drawn the first one, no?
Yes, ma'am, but.
Just think a little bit.
They will not be superimposable images.
Okay, so when they are not mirror images of each other, but they are stereoisomers, that stereoisomers we call it as diastereomers. No. Enantiomers are those which are not superimposable mirror images of each other. They are not mirror images, no? They are non-mirror images. See, there is two things. That we are producing the mirror images and both of the mirror images are superimposable on one another. That is the one part. Second part, I am getting the mirror images, but that mirror images are not superimposable. That are enantiomers. And when the structures are not mirror images, like these are not mirror images, no? Here if you see, this is not mirror images, because if you take or produce a mirror image, this will come here, right?
Yes, ma'am.
And this will come there. So I am getting that thing? No. So superimposable and non-superimposable case will not be there because these are not mirror images of one another. Well, such case is there that they are stereoisomer because the formula is same number of carbon atoms, same number of halogen and everything. But they are not mirror images. Then this compound will be called as, the relation will be diastereomer. Okay? Understood?
Yes, ma'am, understood, ma'am.
So this will be called as diastereomer. So you can write down the relation between these two are diastereomer. Okay? So these are diastereomer. Because these questions generally asked in your exam, Himanish, that they will give you the structures and ask which are enantiomer, which are diastereomer and all. Okay? So these are diastereomer, first and second. Why? Because they are non-mirror images. It's not superimposable or non-superimposable, but about the mirror images. So they are non-mirror images of one another. Non-mirror mirror images. Okay.
Yes, ma'am. Okay, ma'am. Ma'am, your screen is not.
Yeah.
And done. Done, ma'am. Got it.
Got it? Okay. Now I'm giving you one more part here. You know what is tartaric acid?
Ma'am, don't.
Tartaric acid. We are talking about. No? Okay. So tartaric acid will look like this. Here you are having the part OH, OH, H, H, and there will be carboxylic acid present on the system like this. Okay. If you draw another structure for this is first structure. If I draw the second structure, then the second structure will look like this. Yep. OH, H, H, OH, COOH, and COOH. Okay, right? Now you have to produce its mirror image also. That's your task, that you have to draw its mirror image. That is the third one. And then you have to tell me what is the relationship between first and second. First and second, right?
And first and second are non-superimposable.
Just think a little bit and then tell me. First and second, second and third, and first and third. Just see them, draw them, and then tell me. The answer that you are saying, that is not correct. Okay, that's why I'm giving you one more chance. Okay, just do them again. Draw the third part of this. Mirror image of the second one will be the third structure, and then you have to tell the relationship between three of them. This is important. First, okay, tell me in the first part, is it optically active or optically inactive?
First.
The first structure is optically active or optically
inactive? It will be optically inactive, no, first structure.
Yeah, because
plane of symmetry is existing.
Is present, right?
Yes, ma'am.
So we will say plane of symmetry is present here. You can see. So that is why it is optically inactive. Okay. Now in the second one.
Second one, it will be optically active, ma'am. Because
that is why it can make the mirror image. So when you make the mirror image of each other, then what
there will be enantiomers, ma'am.
Yes. So second and third will be enantiomers.
First and COH, HH, OH.
Second and third will be enantiomers. Okay. And first and second will be, I just told you, no?
Diastereomers.
Yes, yes. Okay. And this first is actually a meso compound. I told you about meso compound also, no?
Yes, ma'am.
This is the example of meso compound. Meso compound, right? And the first and seconds are diastereomers. And what is first and third then?
First and third mirror image.
You can tell me the first and third ones are? Just
And there will be dash non enantiomers because it will be non-superimposable only.
But they are not mirror images now, so they will also be diastereomers. When the first is not having any mirror image with the second one, how it will be having with the third one? Let's see.
Yes, ma'am. Yes.
Okay.
Yes, ma'am. Okay, ma'am. Got it.
So the first and second one will also be, and the first and third one will also be diastereomers.
Diastereomers.
Right. So these both are diastereomers. I don't know why it's not writing down there. Leave it. Now what we can see is that all the geometrical isomers are stereoisomers, but if the geometrical isomers are non-mirror images, then they are diastereomers. Okay, that we are getting a conclusion with. What is the conclusion that we have made here? That all geometrical isomerism, geometrical isomers.
Ma'am, your writing is like.
Yeah, I can understand that part. You can see I'm writing, but it's not taking. Because actually we are sharing the screen now. That is maybe.
Now my voice and everything are clear, ma'am.
Yeah, your voice is clear, but I don't know why it's not coming on your like on the website.
Yes, ma'am. Previous in the app also I tried logging all devices, ma'am. It's showing. It's
okay,
loading.
You can try uninstalling the app and then install it again.
No, I tried, ma'am. In the mobile I tried, and after in laptop also I log in. It's showing. It's loading on that.
Because I have just before you know I just took the session, so that was all fine. So if there is something bit up from my side, then it has happened in the previous class also, no? Right?
Yes, ma'am. It's from my side. I think in the app or something. From my side.
Yeah, you can just go with the part and you can just check with the thing that what happened. Okay.
Yes.
I'm saying that all geometrical. I don't know why it's not writing there. Although we are not having that much time also. You can make a line and write down all GI will be equal to stereoisomers. Okay, just write down in your notebook. All GI equals to stereoisomers.
Yes, ma'am. All geometrical will be yes, ma'am. Stereoisomers.
And then put an arrow there and write down non-mirror images, then diastereomers. Okay. Non-mirror images, then diastereomers.
Non-mirror images and diastereomers. Yes, ma'am. Got it.
Okay. Now I'm giving you a question. You have to find out. Write down a question. Find all the isomers of dichloropropane. Okay. So find all the isomers of first is dichloropropane. I'm giving you options as well. Write down the options A, B, C, D.
Dichloropropane.
Propane, yes. And I'm giving you the options. Just write down the options A, 6, B, 5, C, 4, and D, 3.
Total number of isomers, ma'am.
Yes, total number includes your structure isomers also or your optical isomers also. Okay, so both of them. And that also includes optically active and optically inactive. Okay, so yes, total means total, right?
Yes, ma'am. All.
Yeah, so you have to draw it for, and I have given you options also 6, 5, 4, 3. The answer will be any one of them. And you have to do the same for next compound, which is trichloropropane. Okay, next will be trichloropropane. Trichloropropane. Am I audible?
Yes, ma'am. You are audible, ma'am. Dichloropropane and trichloropropane. That's.
Yes. Okay, you can do it now.
Yes, ma'am. Doing, ma'am.
You have to tell all like structures, one optically active, one optically inactive, one. Okay.
Dichloropropane. Dichloropropane. 1 dichloropropane. 1 2 dichloropropane. 1 3 dichloropropane. 4 dichloro. 4 will be structural isomers. No, only 4 will be present. That also only structural isomerism. Because due to presence of no optical isomers.
Okay, tell me the one that how many optically active, inactive, and structures are present. And total isomers. Just give me the answer. Total isomers from the given options.
Total isomers will be 4, ma'am.
Total will be 5. Now figure out, because there is one optically active also, na? So enantiomers will be there, na? Non-superimposable
Yes, ma'am. Yes, ma'am. Got it.
Got it?
Yes, ma'am. Got it.
Okay. Now you can do the same part for the next question.
Trichloropropane.
Okay.
Doing, ma'am.
In the next class, we will be starting with the racemic mixture. Okay. And in the next class, we will be mainly done with the chapter like this. Not the chapter like this part. Okay. We will see the optical isomerism in the alvenes also for the rest of the things.
Yes, ma'am.
Yeah.
Ma'am, 5 structural isomers and 1
Total
will
will be
6, ma'am, because again one enantiomer pair will be 6 will be total.
yes, absolutely correct. Okay, so you got the part how the question can come.
Yes, ma'am, got it.
Okay, because the questions that I gave you here in the class, these all are JEE papers questions only, or resembling them, right?
Yes,
okay,
ma'am.
so they all are relevant.
Yes, ma'am.
Okay, we will do the next part in the next class, right?
Yes,
Manish?
ma'am. Okay.
Okay, thank you so much, and please check your network. Okay.
Yes, ma'am. Okay. Thank you.